I believe, what number is this? Let's see. Number 2 on yesterday's worksheet. So we learned the rational root theorem yesterday, and we learned that if you take P over Q, where Q is the leading coefficient and P is the ending coefficient here, we can list out all the factors of P and Q, and then we take all the possible P over Qs, which number 2 had a lot. This is a lot, right? This one was kind of a nightmare. These are all the possible rational roots, meaning if it crosses the x-axis and it has a root that can be written as a fraction, it will be in this list right here, for sure. So this is a good way for us to be able to find a rational root. Now the whole reason we learned this yesterday is to do what I'm about to do right now. So now notice on this one, guys, this is a cubic equation. So there should be 3 answers, 3 zeros, 3 answers. And unfortunately in this one, we were able to find all 3. We graphed it, we did the tracing, we found the zeros, and we were able to find all 3. But these 2 were really kind of hard to find. Plus and minus 1 over 6. So I'm going to show you a different way. Since you knew 4, let's say we knew 4. So 4 is a root, right, everybody? So follow me through this. 4 is a whole number root, right? So I'm going to use 4 to do synthetic division to get this down to be a quadratic. And then once it's quadratic, I'm going to use the quadratic formula to solve, to find the 2 additional roots. So I found 4. Now this is, let me show you. So we go through. I write a 4. Remember synthetic division, you set it up like this. Then you take your coefficients and list them out. So we have 36, 144. So 36, 144, -1, -4. And then we draw our line and we start going. Drop down 36. So is everybody following what I'm doing here? Okay. So we're using our whole number root to do synthetic division. Drop down 36. Then you multiply 36 to what's in the square. You always multiply it to what's in the square. And it's -4. Sorry. It was -4. My fault. We got that it was -4, right? It crossed the x-axis at -4, everybody? Wasn't that the root we decided? Okay, sorry. You need to write your signs right. So we drop down 36. 36 times -4 is -144. Add straight down, you get 0. 0 times -4 is 0. Add straight down, you get -1. -1 times -4 is 4. Add straight down, you get 0. Now this will be true every single time if you've done it correctly. If that's a root, then your remainder will be a 0. If that's our remainder, this is our constant. Watch how quick this is, guys. This is our constant, this is our x, this is our x, this is our x squared. So now we know that we have 36x squared plus 0x, so I'm not going to write it, -1. Now can't we solve that one way quickly? Isn't that a quadratic? Yeah, we don't even have to use the quadratic formula in this one. Isolate x squared, so we'll add 1. So we have 36x squared is equal to 1. Divide both sides by 36. So we have x squared. Give myself some room. So we have x squared equal to 1 over 36. And then what do? Square root both sides, right? Square root. We don't forget the plus and minus. And so we have x is equal to, the square root of 1 is 1. The square root of 36 is 6. Look, there's our 2 other answers. So we have all 3 answers, guys. X is equal to -4. X is equal to +1/6. X is equal to -1/6. So do you see how we use the rational root theorem to find a rational root? And if we know a rational root, we can use synthetic division to make it a smaller polynomial, which we want it to be quadratic because we know how to solve all quadratics. Okay? Honestly, depth of knowledge high. This is a pretty, advanced problem. But this is what you're going to be seeing. All right, let's do another one together, and then I'll let you work on just one, and then we'll move on. So we're going to do number 5 together, okay? So now everybody look with me. This one you have to use synthetic division. You have no choice. Or I guess long division, but that would be a nightmare. So let's look at this one. It says use the rational root theorem to list all possible rational roots. So we did that. We listed the possible rational roots. And then we used our calculator, and we found that an actual root was +1/5. So we know that x is equal to, one of our answers is x is equal to +1/5. But that's not, let's say on the test, and I will say, but I want to know all the roots. All right, so it's cubic, so there better be 3 answers. So we need 2 more answers. They aren't, well, and this one's actually, you'll see, we're about to do it. So let's do the same thing we just did. We're going to use our rational root, do synthetic division. It looks scarier than it is. Watch how easy this goes. It goes pretty smooth. So we set up our root in our box. So we set up 1/5. Then we put our coefficients, 5, -11, 7, and -1. We draw our line, drop this straight down. Now if you need a calculator, that's fine. 5 times 1/5. Do it in your calculator or do it in your head. What do you get? 1. You're absolutely right. So we put 1 up here. Add it straight down. -10. -10 times 1/5. Do it in your calculator if you must, or do it in your head. -2. It was positive 1/5, right? Yep, -2. You're absolutely right. Add straight down, we get 5. 5 times 1/5. 1. Add straight down, 0. Now this will always be true if that's really a root. A remainder will be 0 if that's a root. So if this is our remainder, this is our constant, this is our x, this is our x squared. So we have 5x squared minus 10x plus 5. And that's a quadratic. And we know how to solve a quadratic. Unfortunately, we have to use the quadratic formula in this one. Or if it factors, we could use factoring. I want more room than that. Here we go. So let's go through it, guys. It'll be good to practice the quadratic formula. So this is our A, this is our B, this is our C. So x equals the opposite of B. So it should be positive 10, right? Are you following me, guys? Plus or minus the square root of B squared, -10 squared in parentheses, minus 4AC, so AC all over, wow, I can't sing today, all over 2A. So I'm going to simplify it. 10 plus or minus the square root. Now I'm going to type in just this piece into my calculator and simplify it, because I'm not going to type in the square root, because if we can break it down by hand, we have to. So I'm just going to type that piece into my calculator. Everybody should practice it. Everybody type it in real quick, so you can make sure you get it right. So type it in, because that's the biggest part of the quadratic formula. Our students can't type it in. So type in that piece, and what do you get? What do you get? Nope. 0. So we get a 0 all over 10. All right, so what we have, well, what is the square root of 0? 0. So we have 10 plus or minus 0 over 10. Then we split it up. 10 plus 0 over 10. 10 minus 0 over 10. What's 10 plus 0? 10. What's 10 divided by 10? 1. What's 10 minus 0? 10. 10 divided by 10. 1. So we got 1 twice. So you got 1 twice. So our answer is x is equal to, first of all, we have x is equal to positive 1/5, and x is equal to 1 with a multiplicity of 2. Very good. So this would be our answer. Now guys, did we get 3 answers? Yes. So we're good. Now actually, fun fact, wasn't that one of our possible rational roots? Yes. So, I mean, we should have been able to use our calculator to see that as well. Does that make sense, everybody? What happened was we didn't see it because it was 0.99999, which rounds to be 1. So that's why we missed that one. Does that make sense, everybody? But at least this way we were able to get it. Okay, you guys try problem number 3. Find the 2 other roots on number 3. Ready, set, go. Okay, so to today's lesson. Today's lesson is actually quite easy because we just use our calculator to do the majority of it, which is awesome, but you have to know what you're doing. So pay close attention. A couple little things you'll have to have memorized. So today we're going to be doing polynomials in real-world situations. So we're going to be given data, and this is something very similar to what an actual statistician in the real world they'd be given. So companies, even like Vivint, they'll hire these mathematicians, especially statisticians, to come in and they'll calculate data for them. And if you become an actuary, you do a lot of stuff like this, and you make the big bucks. All right, so we're going to be given data either in XY points or in an XY table, but we know XY points and XY tables are the same thing, they just look differently. And we're going to be finding the polynomial that matches the data. Okay, first thing you have to know is the n plus 1 point principle. So for any set of n plus 1 points in the coordinate plane that pass the vertical line test, so just meaning if we have a function and it's in xy points, so it has to be a function, which we're not going to give you anything that's not a function, so that's why it passes the vertical line test, that qualifies it to be a function. So if we have a set of points, there's a unique polynomial of degree n that fits the points perfectly. So once again, if you have a set of points, there is a polynomial that fits the points perfectly. Now the n plus 1 point principle. If you have n plus 1 points, then it's degree n. What do you notice about degree n? Isn't it 1 less than the n plus 1? Is it plus 1, n plus 1? Isn't n 1 less than n plus 1?
Yeah.
Yes. Okay, so we all understand that. So it says, what's the polynomial function? What polynomial function has a graph that passes through these 4 points? So how many points do we have? 1, 2, 3, 4. So there are 4 points. So there's 1 less than that degree. So it's degree what? 1 less than that.
3.
Degree 3. So we're going to use degree 3. All right, so then we just simply type it into our calculators. Type it into our calculators and have it do the work. Here we go. Guys, there's too much talking and it's way rude. Here we go. So we go to stat, edit. I gotta get this out of the way. Stat, edit, enter. And then in list 1, we put in our x values. We have done this before. So we have our x values are 0, 0, enter, 1, enter, 2, negative 1. Now make sure there's nothing extra, so I gotta delete that because there's something extra in there. I scroll over. Now make sure you put in your y values that match up with your x values. So it was negative 3, negative 1, 5, and 7. And then make sure you don't have anything extra or it's gonna say error. Now I'm gonna warn you, be very careful today because I even put a note to myself on my lesson plan. Students made errors in typing it into their calculators and it made it really difficult because you couldn't help everybody. So just type it in correctly. All right, is everybody good with how to type it in? Then you hit the stat key again, over to calculate. Now we're calculating a cubic because of the n plus 1 point principle, we're doing a cubic regression line. So the cubic regression line. And you enter through. This is our cubic regression line. Let's see. I didn't have that on my notes. Let me. Hold on. Did I type something in wrong? They're gonna come out hideous. I mean, like they'll be like that, but on my notes I didn't have that. Let me just check my points. Negative 1, 5, negative 7. That's why. It's supposed to be negative 7. Okay, sorry about that. Negative 7. But we aren't going to have beautiful, why isn't it typing a negative? Negative 7. Okay, there we go. Okay, so sorry, calculate cubic regression line. Well, like I said, you won't be alarmed today when you do get decimals because we will, but I just know on my notes. So as you can see, I typed in one little negative wrong and it was just a disaster. There we go. So A is equal to 1, B is equal to negative 1, C is equal to 2, and D is equal to negative 3. So it's cubic, so it goes in that order. So we just write it in. So y equals. So this is the polynomial. Y equals 1x cubed, since A was 1, minus 1x squared, since B was negative 1, and then plus 2x minus 3. But we don't write in the ones. So now I'm going to erase the ones. Is everybody okay with that?
Where did you get the numbers?
On my calculator.
No, what did you ask?
The number is like,
the second set of numbers that you typed in on the right side?
Those are your y values.
Okay.
Yeah. X values go in list 1.
What was the one you deleted or something? You had like an actual.
Because I accidentally didn't type in -7. I typed in +7, so it was just wrong.
We're special.
Does that make sense?
So you have.
You have to type it in right.
Yeah. You have 4 points, but you said you did.
Oh, yeah, it's the n+1 point principle. Because we have 4 points, there's one less than that degree. So it's cubic. Okay, another one. Let's see, it says, what's the polynomial function that graph passes through these 4 points? How many points do we have?
3.
3. So the n+1, yeah, it's quadratic. So it's going to be degree 2. Okay.
4 points.
What? Because in this problem, there's only 3. So then we type it into our calculator. Once again. You guys type it in so I don't have to. It takes me too long.
Stat.
On this thing up here, it takes too long. A is equal to 2, B is equal to 3, C is equal to 6. So that means we have 2x squared, since it's quadratic, plus 3x plus 6. Did everybody get that?
Yes.
That is the polynomial that matches those points. So not too hard, right? That's all you have to do. All right, so do problems. Oh wait, no, one more. Let's just keep going, and then you'll just have a lot of time to work. Okay, so next thing, guys. Well, let's have you work. I'm gonna have you do problems 1 through 4. Ready, set, go. Talk anymore. Okay. So now, this next part, you've got to be a little bit, it's not any harder, a little bit more particular with a few details here. So it says, a table represents the production of milk production from 1955 to 2005. Now I'm going to tell you which model to use. So notice, I highlighted it on here. Find a linear model that best fits this data. So here's our year, here's our milk production. Now here's the important part. Here's the important part, listen carefully. You've got to read this piece. It says, let x be the number of years after 1900. So x values, let's look at our x values. These are years, these are our x values. How many years after 1900? In 1955. How many years after 1900?
55.
So we're going to write for x 55. Okay, how many in 1980? How many years after 1900?
80.
80, and how many here?
105.
You're absolutely right. 105. That's what we have to type in as our x values. Does that make sense? So let's type it into our calculator. So you have 55, 80, and 105. And then we have 16.5. Sorry, I had this written down and I don't know what happened to it. 22.9. Okay, so we type it into our calculator. And we were told we're finding a linear model. So just type it in. Stat, edit. The x part you have to type in right. If you type in 1955, you're not going to get the same regression line as us. So 55, enter. 80, enter. 105, enter.
That was fun.
And don't have anything extra or you'll get it wrong, so delete. 16.5. 22.4. 22.9. Gosh, it takes forever to type it in on this thing. Okay, so then I hit stat, over to calculate, linear regression. Okay, here it is. 0.128x plus 10.36. So 0.128x plus 10.36.
Those are only all to go one line.
So our function, y is equal to 10, wait, what was it? Short-term memory loss, 0.128x plus 10.6. Guys, there's way too much talking, and I'm pretty sure it's not about math, and that's kind of annoying. Okay, so now we've figured out the polynomial. So it says, what is the production of milk in year 2003? So now we need to know what is the production of milk in year 2003. Now the reason that like Vivint would hire someone to figure this out is once they know this polynomial, they can use it to estimate values in the future without having to just wait and see. So now, what's our production of milk in year 2003? So what are we plugging in for x? How many years is after 1900 is 2003? 103. So we've got to plug in 103 for x. So we're going to do 0.128. Now you should type it in for me. We'll get through this much quicker. 103 plus 10.6. I'm plugging it in for x. So what was the production of milk in the year 2003?
It's 10.36.
10 point.
What she said.
It's 10.36? You type it in.
Like 10.6.
Oh, 10.36. Okay, thank you. 10.36. So type it in for me. What do we get?
So you got 103 from 19. Okay. If I had
Right.
this yet, watch it.
We're plugging it in for x.
Oh. Okay, I'm
Okay.
gonna need it, sorry.
What do we get? 23.5. Okay, awesome. 23.5. So our answer is 23.5. Okay, good. All right, next one. One more, because this one's a little bit trickier. Everybody, last one, then I'm going to let you work for pretty much the rest of the time. Find the cubic polynomial that matches the data for world population. So now, this is the most important part. What is x? X is years after 1972. So what's in 1972? How many years after 1972 is that?
0.
0. So we got to plug in a 0 for x. How about 82? How many years
10.
after? 10. How many years after 72?
20.
And then how about here?
30. No. 30. 30.
Okay.
Is that right?
So plug it in to your calculator.
Kind of hesitated.
So let's plug it into our calculator. So 0, 10, 20, and 30. You guys type it in for me. Practice typing it in so it doesn't take me forever to type it in by clicking around.
Oh, yeah.
And which, we're doing a cubic. Guys, you should be typing it in. Okay, so it's not very pretty of an answer. This is our answer. You're going to see answers like this, guys, and they're not very pretty. So we have negative 8.3 times 10 raised to the negative 6x cubed. And then we have plus 2.5 times 10 to the negative 4th x squared comes after x cubed. And then minus 0.0246666667x.
Can you just put
We don't want to round too hastily. Most of yours will come out a little bit prettier
what
than
if you
this.
just put a line above it? Like me.
It's just when you're typing it in, you don't want to round too hastily because it will come out a little different. And guys, it's not even going to hurt you. Okay, plus 1.96. That's our polynomial. All right, so it says, what's the average growth rate in year 2012? So this is the important part. What is our x? How many years after 1972 is 2012? So 72, 82, 92, right? That's 30 years
Yes.
at 92.
No.
20 years.
20 years.
20.
20. Yeah, 20. And then in 2002 is 30, and so on. So what's our x going to be? 30? No, more than that.
40. I said 40. Because you know you have that.
Oh, 19. Oh,
10
what am I
plus
looking
2.
at?
10
Well,
plus 2
yeah,
is 12.
it's 40. Sorry, my fault.
Simple math. So you put 48 on the x's.
So you put in 40 into x's. So you'll type it into your calculator. Negative 8.3 times 10 times 10 raised to the negative 6. Then parentheses times 40 cubed. Yikes, this is not fun to type in.
You have to put x cubed and x squared and all that too.
Well, you don't put in x squared, we're plugging in, right?
Yeah, so
40 squared cubed, yeah. And then plus 2.5 times 10 raised to the negative 4 times. You gotta put things in parentheses, guys. Squared. And then minus
Stop.
Okay.
7 times 40 plus Yeah, you gotta use parentheses like a maniac in this one.
It's going weird. No.
Okay. Sorry, I'm retyping it in because I didn't type it in right. Let me push pause on my videos. So you've got to use parentheses like a maniac, so 0.442. I'm going to retype it in a second just to be a little bit more precise. But I think I got 0.442, which wouldn't be unreasonable, I guess, since it's getting smaller and smaller. I'm going to type it in again in a second. All right. So do problems 5 through 9. Now here, it doesn't say on your thing, but I'm telling you, for number 5, use a cubic model. For 6, 7, and 8, use a quadratic model. And for number 9, you should know how to do that. You take differences to find the degree. Just remember this. Okay, so this is just going to help you if you pay attention to this. So recall, to name or classify. Name and classify means the same thing. To name a polynomial, you must combine all like terms, and you must put it in standard form. Once you've done those two things, you name it by, there's two names. The first name is the highest degree. The second name comes from the number of terms. So 2x cubed minus 5x, it is the highest degree is 3, so it's a cubic, and there's 2 terms, so it's a binomial. It's a cubic binomial.
What?
Okay, this part has probably been the longest time, so everybody should be paying attention to this. So it says, let's recall what end behavior of graphs looks like. Remember, if it's an even degree, you should all be paying attention. I know you won't be able to do it, and I'm not going to answer your question when you can't do it. If it's an even degree, it has the same end behavior, either up and up or down and down. Now determine if it's up and up. If it's up and up, it has a positive leading coefficient. So an example of something that would be up and up would be 2, isn't that positive? And then x squared, isn't that an even? Even and positive, so it's up and up. Okay, now down and down. It's an even end behavior, an even degree, but then it has a negative leading coefficient. So an example of that would be negative 2x to the 4th. Even degree, but negative in front. That flips it upside down and down. Then, if it is an odd degree, it has opposite end behavior, either up and down or down and up. Now, these work the same way as a line. Picture a line. This is a negative line. So, negative, an example of an odd degree would be like negative 2x. Isn't that a line? For example, and that would have up and down behavior because it's going down. All right, and then down and up. Now, once again, notice it looks like a line that's increasing. It will have an odd degree. So, for example, it will be like x cubed could work. And then if it's positive in front, positive 1 in front, then it will be down and up because it's increasing. Does that make sense, everybody? Okay, so now you should be able to finish the worksheet.
Oh.
Review problem.